Okay, here's a great question. You're asked to factor that polynomial right there. So you can do the AC method. So 36 times 105 is a crazy stupid number. So it has to multiply to a negative 370 and it has to add to a positive 39. Good. And so here's all the options. No. Impressive. Like this, showing that. It's nice to be able to guess it like on the first couple, but this shows understanding of what the concept's all about. So we found some 45 and 84. It has to be negative, right? So I have to have a negative number, and so I have to have a negative and a positive down here. And because this is positive, the larger of those two has to be positive. So this has to be positive, that has to be a negative. Okay, and so that's what we did here. So we replaced the minus 39b with those two. Then we do our group factoring, take 12b out of the first, perfect. Negative 15 out of the next one. Notice that when you take a negative out, that sign changes, perfect. And so your factorization comes out to this. To check, you can check that, that's perfect. The only thing you could have done at this point is look for a common factor. So here between 12 and 15, there's a common 3 that I could have taken out. And so if I take a 3 out, then I'm left with 4b minus 5. And I'd probably rewrite that with the 3 out front, and then 3b plus 7, and 4b minus 5. Excellent work. Now, one thing you could have done, maybe to save you a little bit of that work, is at this point 36b squared plus 39b minus 105. You could look to see if there's a number that'll divide evenly into all of those. And you guessed it, it's probably 3. So I could have taken a 3 out to begin with, and it'd be 12b squared plus 13b minus 35. And then I could have done my AC method with that. So 12 times 35, that's 350 plus 70 is 420. So what things multiply to a negative 420 and add to positive 13. Then your options, you might have fewer options to find out. But in the end, you would have come up with the same answer. Excellent work.